And in the DC circuit, actually, initially we have some symbols, right? But that symbols are not much important because that symbol we can easily identify during the topic. So we are not going to discuss all that symbols or electrical symbols for each and every component, because during the topic or during the question we can easily identify and we can memorize the symbols, right? So let's suppose if we start with the concept of EMF. So you know about the journal between EMF and potential difference, right?
Yeah.
Because electro EMF is the electromotive force, and there is also a clear difference between EMF and potential difference in our IGCSE syllabus, right? So basically, EMF is actually related to the source. Source means, let's suppose if we are talking about a battery or a dry cell. So in dry cell or a battery, there is a chemical energy, right? So chemical energy is actually converts into the electrical one, right? So the amount of chemical energy that actually converts into electrical energy per coulomb charge, right, passing through a power supply, so that is known as EMF, right? So basically we can say that EMF is the amount of chemical energy converted to the electrical energy per coulomb of charge passes through a power supply. Because this is the only main difference that easily help us to identify that EMF is actually linked with the power supply, right, or with the power source, whereas the potential difference is linked with the components connected in the circuit, right?
Yeah.
So passes through a source. So this is the journal definition for EMF, and we know that we can use the same formula for EMF that we use to write for the potential difference, right? Because there is no such difference between them, because that was also energy, this is also energy. So rate of doing work, because work or the SI unit of work is also the same joules, and in electrical we used to use the same concept, right, Dex? So that's why there is not a critical difference between the formula or anything. We know that the SI unit is also same like the potential difference, right? So that is remains the same. Only it is energy transfer from one form to another, and in potential difference, it is electrical energy transfer from or energy transfer from electrical one to the other forms, right? Let's suppose if a lamp is connected, so we know that electrical energy is actually converting into the light energy, right? This cycle is a very simple. Let's suppose if we use a cell, so cell give us chemical energy. We are getting chemical energy, and that chemical energy converts into electrical energy. So this specific slot or this specific part is known as for EMF, right?
Yep.
And next, if we continue the concept, now we are having a bulb or any different component connected in the circuit. Let's suppose if we talk about the lamp, so lamp gives you light energy. Electrical or this journey electrical to the light energy is related to the potential this is the part of potential difference, right? So this is the difference during the cycle. And we already discussed about potential difference. Now the new concept related to the EMF is the internal resistance, right? We already know about the external resistance. We drive the formula for that. We discuss the derivation for that. And we also talk about the factor affecting resistance. So the new concept is related to internal resistance. This is new topic.
Okay.
So internal resistance is our concept, and internal resistance is a very simple concept initially, because we know that whenever we are using any type of source, so those sources or those batteries or cell are also made up of a type of conductors, right? Different conductors, different materials. So when charges are going to move from, or energy is going to convert from one form to another, so we know that battery got heat up after some time, right? Each source actually heats up after some time. It means that not 100% energy is actually converting from chemical to electrical, right? Or any form to the electrical one, right? There,
Going to be.
yes, it is actually there is a little part of that that actually converts into the heat energy, right? So that heat energy is like a wasteful energy for us, because we are not going to use that heat energy in our circuit. So that is the difference, right? So actually our main purpose is to find out that internal resistance that produces that thermal energy, right? So that is the concept that we need to discuss. Okay. So definition will be, or it is not like a definition, it is just like a concept that all power supplies. And by the mean of power supply, we are also talking about cell batteries, AC, DC, all the power supplies, all the sources, right?
Yeah, okay.
All power supplies have some resistance
Mm-hmm.
between their terminals. And in short, this resistance is actually known as internal resistance, right? Because this is internal, we are not able to find out that value, right? Because let's suppose if we connect a whole circuit with a battery or a cell, so we can easily we can only measure the resistance of wire or the resistance of a resistor that is connected in the circuit. So we are not able to find out the value of internal resistance in normal conditions, right? But if we specifically want to calculate that value, so it is possible to calculate that value. So let's suppose we already discussed the whole concept that how this resistance produce, we can identify this resistance with the heating effect, right? And this that heating effect will also lose your power or lose the energy or lose the voltage, right, from the supply. So this internal resistance actually causes loss of voltage, power, or energy, right? Anything you need to mention? No, all are interconnected. We can easily just transform from one point to another. So let's suppose if we connect, or if we consider a single circuit first, then we try to apply the concept and try to find out the formula, how formula can be applied. Now we are talking about internal resistance. So in diagram, there is a specific pattern or a symbol to identify that they are talking about internal resistance, right? So first of all, let's suppose if we are having a battery or a source. So this is our source, symbol for resistance. Now each and every question, there will be a dotted line or a box around the battery with resistor. So that gives you the concept. Let's suppose if we just mark around it, and that is also going to be marked in your exams also, because that is very much important. Because in diagram, this is the only thing that gives you the identification of internal resistance, right? Because this specific box gives you the concept battery plus resistance. It means internal resistance, right? This is not external. Okay. External
Okay.
is connected over here. This is our external resistance, or we usually write internal resistance with a small r because that was the smallest one. This is the largest one as compared to that one. Okay. This is the ray diagram or the circuit diagram for circuit, and we can easily measure the voltage from this side, right? So this is the situation that how we can identify the internal resistance. So this is our internal resistance.
And then overall, like outside of this dotted box, it's going to be external resistance, right?
Yes,
Because it's like everything. And
yes.
internal is just like in a specific, like a specified area which the
Yes.
examiner gives you.
Yes. Mostly it will be like a proper box with a shaded color, gray color, right? I'm not going to shade over here because it will be like a single color. So maybe a dotted line, or mostly a box with shaded line, sorry, shaded, that we observe in our exam. So the main thing is that there will be a specific box, because there must be a box that gives you the concept. And one more thing is small r. Small r is for internal resistance. So this is the circuit diagram that gives you the hint that how we are going to use that internal resistance, right? So we know that when we connect any load with the battery, so current starts to flow through that load, and when current starts move through the circuit, or there will be a value of voltage, right? So voltage is also going to be, or we can say that the energy or power is also going to be lost in form of heat because of that internal resistance, right?
Yeah.
And let's suppose we know that energy will remain conserved, right? So according to law of conservation of energy, let's suppose if we just write a journal concept, right? Then we comes to the formula. Let's suppose if we want to find out the lost volts, the voltage that is actually lost. So generally we can find out with the help of total EMF, right? Because EMF is the basic thing. It is connected to the source. So EMF minus terminal potential difference, right? Because first we need to find out the total value of voltage that is connected with the battery. Then we need to find out the potential difference throughout the circuit. So then we can easily subtract and find out the value that initially what we are getting and finally what we are receiving. So there will be always a difference because of that internal resistance, right?
Yeah.
And your final formula or your final equation for this internal resistance will be look like this, equals to IR plus IR, right? Or we can just simply write it as take I common, R plus R. Okay. So E is the EMF. And if we talk about IR, so this first IR is the combined terminal potential difference, because we know that V is equals to IR. This is our terminal potential difference. Can also identify with that capital R. Capital R means external load. Small r is the lost volts or the internal resistance. Okay, so this is the formula, right? Or for the second term, if we want to define the second term, so in second term current is actually separated, so that is a single value of current. Then R is the external or the load. Now this will be the external resistance or the load, and this small r will be internal resistance. Clear? Any confusion?
No, it's good. Can you go up a bit? I just want to see the lost volts thing again. So the lost, like the number of volts which are lost is going to be the EMF minus the terminal potential difference.
Yes, yes, because current starts to move from positive side, and
Yeah, yeah.
that load is, oh sorry, that internal resistance is on right hand side. Okay, so initially the EMF minus potential difference, and then remaining part will be the lost volt, right? So we
Yep.
used to make diagram like this, so that will be easy for us to identify that what actually happens in the circuit. Okay, let's suppose if we just consider a simple circuit initially. Let's suppose we are having a power source. So this will be our power source, and the value of this component is 9.5 ohms. It is connected with this load. And finally, we are having a box, and the battery has the EMF 7.3 volt. Sorry, it is not terminal, it is internal resistance. I am writing with the small r. Right, so this is the value. Okay, now what you need to find, there are two unknown things that you need to find. First one is the current in the circuit, right? So you need to find out the current in the circuit, and the second one is lost volts from the battery.
Okay, so like what I'm gonna do first is I'm gonna like do 7.3 equals to I, which we don't know. We don't know the
Okay,
current.
yes.
Inside, and then I like have brackets, and inside the brackets, I'm gonna have 9.5 plus 0.3, so it's gonna give me 9.8, and
Mm,
then I'm gonna do 7.3 divided by
yes,
9.8 to find
yes,
the
so
current.
that will be give you the value of current, right? That's
Give
right.
me 0.74489, or like we'll just do it like 0.75.
Okay, so 7.3 is the value of voltage divided by the combined resistance. As you already says that we need to add them up to the formula. So your final value is in amperes, that is for electric current. And then you need to find out the lost volts. So how we can find out the lost volts?
To find out the lost volts, we have the formula lost volts equals to EMF minus the terminal PD. So we're gonna do 7.3,
Mhm.
and
Okay,
you're gonna subtract I multiplied by R, which is gonna be 0.75 multiplied by 9.5.
okay, okay. You may do one more thing that is very simple. In the above formula, it is mentioned lost volt. So lost volt can easily be find out with I into small r, right?
But the answer is 0.22. If
Yes, if you just multiply and that process you mentioned, so you will get 0.22. And if you just write for this, so you will also get the same result 0.2 with the lost volts value for this formula. Like if you want to calculate the lost volts, so we can use this equation. So it's up to you if you are going to calculate the lost volt, calculate by the reference of this formula, right? So this is also simple. And if you want to go with your method, so that is also right. You will get the same answer 0.2. Okay. So this will be our answer. Okay.
Yep.
Again, two significant figures, you may round it off. So this is the basic concept of internal resistance, right?
Okay, so it's kind of easy. You just need to know the two formulas. That's it.
Yes. But when we try to solve in our past papers questions, so there are some typical one also, but we, because there is a mixture of all the concepts, so it will be like two or three working calculation that we are working at the same time. So that will make us confused because we don't know which value is right for this one. So we will also solve that one because there will be a complex circuit. This is only for a single one, so that's why it is easy, right? But when we are solving a whole circuit, the complex circuit, so sometimes it's difficult to identify the actual values, right? Because there are
Yep.
multiple value of current, resistance, voltage, and we are just finding the way which will give us the final value, right? Okay, one more thing. There is a new concept which is related to the Kirchhoff's rule, that is for the electric current. Rule is not much very difficult. We already know about that concept, but that is a new topic because you need to know about the name of that law, because sometimes they ask you that write the Kirchhoff's first rule, Kirchhoff's second rule. So we need to know about the rule and the statement of that rule. Okay.
Okay.